Join me as I dive into the science and see if I can explain what makes James Webb's golden mirrors so powerful. The James Webb Space Telescope is a marvel of modern engineering, and one of its most distinctive features is the golden mirrors that make up its primary optics. In this video, you'll discover what makes these mirrors so revolutionary in the field of astronomy and space exploration. For decades, telescopes have been our eyes on the universe, allowing us to study distant galaxies, stars, and planets. But previous telescopes had limitations. They could only observe the universe in certain wavelengths of light, like visible light. This made it difficult to study objects that emit light in other wavelengths, like infrared. The universe is full of mysteries, and we needed a new way to explore it. The problem with previous telescopes was that they couldn't observe the universe in infrared light. This made it hard to study distant galaxies, which are often too cool to emit visible light. Astronomers needed a new technology to observe these galaxies and other cosmic phenomena. They needed a telescope that could see in infrared light. One of the main challenges was designing a telescope that could detect the faint signals from distant galaxies. These signals are often weak and can be easily overwhelmed by background noise. The solution was to build a telescope with a huge mirror that could collect more light and produce sharper images. But there was still the question of what material to use for the mirror. The James Webb Space Telescope's mirrors are made of gold, which might seem like an unusual choice. But gold has some unique properties that make it perfect for this application. It's an excellent reflector of infrared light, which is the type of light that the telescope is designed to detect. By using gold, the mirrors can capture more light and produce sharper images. The mirrors are made up of 18 hexagonal segments, which are designed to unfold in space. This unique design allows the telescope to have a huge collecting area, which is essential for detecting the faint signals from distant galaxies. The gold coating on the mirrors is incredibly thin, just a few layers of atoms thick. Despite its thinness, it's incredibly effective at reflecting infrared light. The use of gold on the mirrors improves light capture and image clarity in a few ways. For one, it's a very efficient reflector of infrared light. This means that more of the light that hits the mirror is reflected, rather than being absorbed or scattered. This results in sharper images and more accurate data. The James Webb Space Telescope's mirrors are truly groundbreaking, and they're going to open up new doors for scientific discovery. By capturing infrared light, astronomers will be able to study objects that were previously invisible. This includes distant galaxies, stars, and planets. The telescope will be able to study the formation of the first galaxies in the universe, as well as the formation of stars and planets. The ability to capture infrared light will allow astronomers to study the composition of distant objects. This includes the atmospheres of planets, which could potentially harbor life. The telescope will also be able to study the formation of planets and the delivery of organic molecules to Earth. The James Webb Space Telescope's mirrors are a key part of its mission to explore the universe in infrared light. By using gold, the mirrors can capture more light and produce sharper images. This will allow astronomers to study the universe in ways that were previously impossible. In summary, the James Webb's golden mirrors are a crucial part of its mission to explore the universe. They allow the telescope to capture infrared light and produce sharper images. This will open up new doors for scientific discovery and allow us to study the universe in ways that were previously impossible. If you have any thoughts on the James Webb Space Telescope or its incredible mirrors, leave them in the comments below. Don't forget to subscribe for more exciting content about space exploration.